if I want to add up vectors graphically, and I just needed drawing, all I have to do is I draw one vector. So I would draw the red vector, and then I would draw the green vector so that its tail comes out of the tip of the red vector. And then my resultant vector would span from the tail of the first one I drew to the tip of the last one that I drew. So there's my resultant vector. And the components of the resultant vector, well, I've got nothing in y, so I just have what? 1, 2, 3, 4, 5, negative 5, 0. There's the location of the tip of the last vector, right? Now, I want to show you another way to add up vectors. If I just find the x component, which is negative 2, and the y component of this vector, which is negative 3. Let's see, it's x equals, y equals, right? And then let's see, the x component of this one is x equals negative 3, and the y component of this equals 3. All I have to do is add the x and the y from both vectors, and I will get the resultant vector of these two as well. So let's see, x is going to equal negative 3 plus negative 2. So it's negative 5, and y is going to equal 3 plus negative 3, which gets us 0. So the resultant vector is negative 5, 0, if you add these two up that way. And look at that. I get the same answer, and those were both the same vectors that I drew. So what does that mean for us? Well, what if I'm supposed to find the resultant vector from these two vectors? And these don't perfectly fit on the square, so I really can't just draw it out graphically. I'm going to have to actually figure it out with a little bit of trigonometry. So let's start with the red one. I can do the same thing, right? I can figure out the x component and the y component of the red one, and then add them up, and that will get me the x and y component of the resultant vector, right? So looks like my x is my opposite this time. So I'm going to say x equals 2 sine 30, and that is 1 Newton. And then my y is the adjacent, so y equals 2 cosine 30, and that gets me 1.7 newtons. Now let's do the other one here. All right, so there's my y component, there's my x, so there's my triangle, right? So it looks like in this case, my x is now my adjacent, so x equals 4 cosine 45, and that equals 2.8 newtons. And then y equals 4 sine 45, and that is also 2.8 newtons because I've got a 45-degree angle. So what do? Well, now if I want to get my resultant vector, or at least the components of it, I know that x is going to equal 1 plus negative, oops, so this is a negative here. I almost forgot, right? This, remember, it's going this way. So that's a negative 2 points. So 1 plus negative 2.8. And then y, let's see, the y's are both positive. So it's going to be 1.7 plus 2.8. And that's going to get me 4.5. Right? So that's, I probably should finish the math there. That's negative 1.8 in x. So let's draw that. X was negative 1.8. Let's say that's about there-ish. And then 1, 2, 3, 4. 1, 2, 3, 4, 4.5. We'll say it's about there. So that's roughly there. So this is my resultant vector when I add those two vectors. And that makes sense, right? Because I had like something like that plus something like that, right? So Now all I have to do, if I want to get the angle and really figure this totally out, right? I know that this is 1.8, and I know that this is, oh wow, that was funny. And I know that this is 4.5. So in order to find my magnitude, I can just say that the magnitude is going to be the square root of 1.8 squared plus 4.5 squared. So the magnitude is 4.8 newtons, right? So I know that this is 4.8. And then if I want the angle, well, I'm just going to take the inverse tangent of 1.8 over 4.5, and that will get me 21 degrees. So this is 21 degrees west of north, and it's 4.8 newtons. So there you go.